You have to unmute. It, Teacher, you have to unmute. No. I can't hear you. We can't hear you because you have to unmute too.
Okay, got it. I'm so sorry. Okay. I'm so sorry. Okay, I gave all my introduction and I thought you're able to hear me. Sorry about that. Well, welcome to Science Matters. My name is Anna, and let's start with introductions. I want you to tell your name, what grade you're in, and let's say what's your favorite thing to do in your free time. Okay, so and where do you live? I'll start with me. My name is Anna, and I live here in Phoenix, Arizona. And my favorite thing to do is play board games with my family. So let's start with Connor. Do you guys know how to unmute yourself from your side? Give me thumbs up if you know. Okay, great. If you don't, wave at me. Okay, looks like everybody knows. So Connor, it's your chance. It's your turn.
My name is Connor. And I'm in kindergarten.
And what's your favorite thing to do in your free time? Playing with friends, video games. What do you like to do?
Watch our show.
Oh, nice. Great. Well, welcome, Connor. Alex. Thank you. Thank you for introduction.
My name is Alex and I live in Fort Collins, Colorado. Mm-hmm. And my favorite thing to do in my free time is play video games.
Awesome. Well, welcome, Alex. Tanish.
One of them should be here. Yep, someone's here.
Yes. Okay, Tanish, it's your chance.
My name is Tanish. And my favorite thing to do is play my Xbox. And I live in Scottsdale, Arizona.
Welcome. What grade? Third grade. Welcome, Tanish. Sean.
My name's Sean, and I like to do is play Slime Rancher on my mom's computer.
Oh, wow. What grade are you in? Nice. You're in kindergarten?
Mm-hmm.
Welcome. I love to play that game too. Great. Noah.
Hi, my name is Noah, and my favorite thing I like to do is be with my family.
Oh, that's so sweet. What grade are you in?
First grade.
First grade. Welcome, Noah. Samuel.
Samuel. My name is Samuel, and I'm in first grade.
And what do you like to do in your free time?
Play with my friends.
Awesome. Great. Welcome, Samuel. Lucas.
Hi, my name is Lucas, and my favorite thing to do my free time is talk to my magic 8-ball, and I'm in first grade.
Wow. I love Magic 8-Ball too. Great. Welcome, Lucas. Oh, you have it right there. Great. Okay, Sarn.
I like to play Roblox, and I'm in second grade.
Welcome, Sarn.
Like to play Roblox with me.
Well, that was nice. We get to know each other a little bit. Okay, so let's start today's class. Anybody knows what we are going to learn today? Anyone? Well, thank you for raising hand, Noah.
We're going to I forgot.
No, that's okay. Anybody else? Yes, Samuel. Thanks for raising hand, Samuel.
Electromagnets.
You're right, absolutely right. Electromagnets. So before we start our lesson and before that check our list, let's go over some rules. Since this is our first class and it's a virtual class, let's go over some rules.
This is not with me or someone's first class.
Okay, so most of you, all of us will be, except me, will be mute so that we are able to focus on the lesson, okay? And whenever you want to talk, you want to say something, you have a question, or you have a doubt, you just wave at me, or I'll unmute you, or you can unmute yourself. When I ask you guys a question as a group, and you know the answer as a yes, you give me a thumbs up. If you don't know, don't understand it, you either wave at me or give me a thumbs down. Is that clear? Awesome. Everybody knows, right? Okay. Does anybody has any question? No. Okay, great. So let's start by checking our list, okay? So did you all get the lesson 1 supply bag? Okay, great. The only thing we'll need from home is tape. Yeah, there are 2 things, scissor and tape. If you don't have, you guys can get a scissor and a tape. Any kind of tape will be fine. Any kind of tape will be fine. Are we? Yes, absolutely. Any tape is good. Are we all good? Hi, Rem. Hi, my name is Anna. We all introduced ourselves by telling our name, what grade we are in, and one thing we love to do in our free time. Would you like to introduce yourself? Okay. Can you unmute yourself, honey? Okay.
My name is Rem, and I'm in second grade, and I like playing Minecraft and Minecraft Dungeons.
Awesome. Welcome, Rem. So we all have scissor and tape, right? Now let's check the lesson 1 supplies. You all have 2 magnets, right? Give me thumbs up. Yeah, you don't have to show, just give me thumbs up if you have it. Okay, you have a craft stick. Okay, and let's see, okay, toy car. Great. Velcro dots, a bag of dots. So we will need this in next lesson too. So keep it safe, okay, after today's lesson. Then paper clip. Good. And a string. Great. And a paper cup. Awesome. And a paper plate. Okay, good. And the last thing is the sheet. Okay. Okay, now let's start today's lesson. One more thing I want to tell before we start experimenting with magnet. We will be checking different things that attracts to magnet. One thing, you have to make sure that you don't take your magnet near any electronic device like a phone, a tablet, or a computer. We don't want to spoil that, okay?
Because it could wipe your computer memory.
Yes. So you have to be very careful that you don't bring your magnet close to a phone, computer, or a tablet. Is everybody clear? Great. Okay. Now, now do you guys know what a magnet is or what does a magnet do? Raise your hand if you, Sean.
Magnets stick to stuff and they have like metal inside.
Very good. Good answer. Connor.
Magnets stick to metal.
Magnets stick to metal. Very good. So
I have something to add on
Mhm. Yeah.
Sean's. I have something to add on Sean's.
Okay, Alex.
They
Yeah.
don't have metal in them. They are metal.
They are metal.
Which is a similar thing.
Yes.
So
So
that is the exact same thing.
yes. So a magnet can be a rock or a metal that attracts other magnetic metals. So are all metal magnetic? Do you think a magnet can attract all the metals? If you think yes, give me thumbs up. If no, thumbs down. Very good. No. So so have you heard of magnetism? What is magnetism? So the force of a magnet is called magnetism. I want you to take these two magnets, bring it close, and see what happens. They either will stick to each other like this, or if you turn one magnet around, it will push each other or repel each other. Why that's happening?
It has to do with magnetic fields and that kind of stuff.
Okay. So every magnet has two poles. Just like Earth has a North Pole and South Pole, right? A magnet has two poles, North Pole and South Pole. So can we take this sheet out?
I knew that.
Okay, so if you see these two magnets here, when the North Pole of one magnet come closer to the South Pole of the other magnet, they attract each other, they hug each other. But if the North Pole of one magnet come closer to the North Pole of the other magnet, they push each other. So the opposite poles, they attract, the like poles repel. So when I am bringing these two magnets like this, and I see that they just click, it means one is north and the other one is south. But when I flip it, and now they just don't want to be near each other. It means they are either both north or both south. Do you want to test that out? Check that out. So let's do a little bit field work first before we start our experiments. Before we start our field work, let's hypothesize. You know what is hypothesis? Hypotheses is, yes, who knows? Lucas? Okay, yes.
Hey, hypothesis is like a planning chart.
You play what?
Like a planning chart.
Okay, so hypothesis is like when you look at, for example, when you look at this magnet, you think what surfaces this magnet will go stick to. You guess, you make a suggestion. So for example, I guess that this magnet will get attracted to this paper clip. So, and then this is my hypothesis. This is my guess. And now I take the paperclip and test my hypothesis by checking it. And if it works, my hypothesis or my guess was right. And if it doesn't work, my guess was wrong. That's what scientists do. So I want you all to guess or hypothesize one thing in your house that this magnet will get attracted to. And I want you to check that out, whether your hypothesis was right or not. So, and once you do that, you come back and tell me whether your hypothesis was right or not, okay? Hi, Liam. Hi. You just joined, right, Liam? Okay, so do you have your lesson? So while I talk to Liam, I want you all to go look around your house. What are the things this magnet was attracted to? And check your hypotheses too in meanwhile, okay? Okay, I'll give you 2 minutes. Liam, will you like to do that too first? So you have your magnet. I want you to go around and see what this magnet get attached to. Okay?
My prediction is it will get attached to a paper clip.
Yes, when you come back, and I want you to come back, look around the house and see different items. Yes, Noah.
I already knew I already knew some of this, and also I forgot.
Oh, okay, no worries. Noah, you wanted to say something?
Me?
Yeah, I thought you raised your hands.
That I actually didn't raise my hand. I was doing this until my mom said that I could do other things, but I didn't know that.
Okay. No worries.
Yeah.
So I want you all to check few things your magnet get attracted to. Okay, who is ready to share? Samuel.
I got a car, and I guessed that it would stick to it, and it didn't. The bottom of it.
Awesome. Awesome. Who else wants to share? Lucas.
Actually, the items I actually found don't actually connect.
Very
Like I
good.
found a quarter.
Uh-huh.
People.
Okay. Very good. So was that your hypothesis, Lucas?
I was thinking first. I was thinking this would stick, and then I had another thought that this would stick because it's still metal, and I don't know if it's the same type or not.
Very good. Very good. So I thought that too. I have a quarter here, and I thought, okay, this is metal. This might be, magnetic. But when I checked, It's not. Then you know why? Anyone can tell me why? Even though quarter is a metal, but it's not magnetic. Sean, I can't hear you, honey.
Because it wasn't the right way.
It wasn't the right weight, you said?
No, it wasn't the right way.
The right way? Okay, so let me check the other way. It doesn't both ways. No. Good. Good guess though. Tanish.
Because I guess it like the metal doesn't have enough force in it for it to stick.
Okay, that is also a good question. Now, the thing is, the magnet gets attracted to mainly three types of metals: iron, nickel, and cobalt. Now, you know what this quarter made of? It's mostly copper. And the magnet copper is not magnetic. So that's why if you see, I have a copper here, I have a quarter here, I have a nickel here, I have a dime here, and I have a penny too. None of it is magnetic because most of these coins have copper in it, mostly copper. So that's why it's not magnetic. But that was a good hypothesis and good testing. Anyone else wants to share what they checked around their house, which was magnetic? Noah?
I have two. So this case sticks to magnetic, even something like a safe even could even stick, which is magnetic too.
So that probably is either made of iron, nickel, or cobalt. Great. Connor.
So I thought the magnet would stick onto the robot, but it didn't.
It did not. So what do you think this robot is made of?
Plastic.
Yeah, plastic. So it's not metal. So that's really good. So it's not sticking because it's not metal. Anyone else? Okay,
He also
last one, Rem.
has a thing in him, and he also moves because of the button here, but doesn't work anymore.
Oh, okay. Well, thanks for sharing, Connor. Yes, Rem.
So also I just wanted to say not all robots are made of metal.
Very good. That's right. Not all robots are made of metal. Liam. Okay, Sean. I'll come back to Liam in a minute.
I found a bell and it sticked because it was metal, like it was like some kind of metal.
Very good. This you thought? This is what you guessed that it will or hypothesized?
Yeah, but also I thought it would stick to these scissors.
It did?
It did.
Very good. Yeah. So this is magnetic. Yes. Liam, were you able to check something around your house?
Sure.
Unmute yourself, honey.
Yes, I did.
So what did you find?
I found a paper clip.
Was it magnetic?
Yes.
Really good. Okay. So let's check one more thing. I have wood here.
Can I say my things?
Yes. Raise your hand.
So
Okay, yeah. Sorry, I was not sure who's talking. Okay.
I So I tried my paper clip and it stuck. I tried a fridge, it stuck, and my picnic basket handle is like it looks metal, but it wasn't. So when I put it, it didn't stick.
It did not stick. So what do you think? Why?
I think it's because it was like steel. I think.
Very good. So it was not iron, copper, oh sorry, cobalt or nickel. Very good. How about you, Soren? Did you check?
I checked scissors and they worked because they were metal.
Mm-hmm. Great. Okay. So I have this wood. Now, what do you think, this wooden ruler? Do you think the magnet will this will be magnetic? Yes, thumbs up, no, thumbs down. No. Now, do you think that magnet can go through objects? Give me thumbs up if you think yes, thumbs down if no. So I see few thumbs down and few thumbs up, so we can check that out, right? So I want you to take your magnet and, okay, I'm going to show you something. So I have a magnet here and it's just staying there. It's not falling down. Why do you think? Liam?
Because there's a magnet on the backside. Wood is not magnetic.
You are right. Wood is not magnetic. Why this magnet is staying in place? Because there's a magnet back. Awesome answer. So let's try a trick. So I have this paper and a paper clip, and I put it on top. I put the paper clip on top of the paper. You see that? What should I do that it doesn't fall down? Sean.
Put a magnet under it.
Put a magnet under it. I want you all to try that and show me. Yeah.
Let me show you something that I've accidentally figured out before.
Oh, wow.
These scissors are magnetic because there's a magnet on the scissors.
That's really good. That's really good. The magnet
I found that a while ago by accident.
Yeah, you can make it too
Great
much. Right?
observation.
That's not good.
Yes.
But
That's right. So what does this tell us? What does this tell us? Even though we put the magnet behind the paper.
Only when it's not even on.
Listen.
What does this tell us about magnet? Like we put the magnet here on the wooden ruler, both sides, and magnet, it did not fall off. What does this tell about the magnet? Noah?
That the ruler is actually made out of any thing that can stick to this.
So the ruler is wood. If I just keep a magnet here, it's gonna fall down. Why it's staying there, because there is a magnet behind it. So what does that mean? It means the force of the magnet can go through objects. It can go through the object. So let's test that out with our first experiment. I want you to take your paper plate out. And the paper clip. And paper cup. And the last thing is the string. Okay. the first thing I want you to do is tie your string to the paper clip, okay? One end of the string.
I don't know how to tie.
Raise your hand. If do you have anyone to help to tie?
Yeah.
Okay. If you don't know, if you don't have, I can show you another way probably that will work. But if you don't know how to tie, the best way to do is stick the tape to the paper clip. Use a tape and stick it. Give me thumbs up if you're done. Thank you, Sean, Samuel, Liam. Great job. Okay, Noah, yes. You have a question?
So how do you tie it? Because my mom doesn't know how to like.
You don't have to tie. You can use a tape and tape the string to the paper clip.
Okay.
Yeah. It's a really kind of narrow thread. It's hard to tie.
Is it like this?
Yes. So it'll be like this. Whoops. Or you can tape it.
I just found out that if you put magnets on both sides of the paper clip and keep the paper clip out a little bit, kind of looks like a paper clipper magnet sandwich.
Yeah, that's right. Okay, everybody done taping or putting a knot? Okay, I'll give you a few more seconds. Okay, give me thumbs up if you're done. Great. Those who are done taping or putting a knot on the clip, you will tape the other end of your string to the plate. So I'll show you. So right here, tape it to the plate. Yes, Samuel.
Do we tape the paper clip or the end of the string?
The end of this thing, the other end of the string. So
Is the paper clip at the other end of the string and it goes on the paper clip?
So this is the one end on the paper clip and the other end on the plate. Like this.
You do it like that?
So let me make myself, okay, right. Okay, can you all see? Okay, are we all good?
We can't see the paper clip, but everything else is fine. This is what we see. Kinda.
Yes, yes. So now, shall we move to the next step? Thumbs up. Everybody good? Okay, Liam or Lucas? Okay, good. Now what you're gonna do is put your plate on top of the table and put the magnet into the cup, paper cup. Put your magnet in the cup. Okay. Now let me show.
Is there a way it needs to face?
No, it doesn't matter. Okay, I'm going to show you my work area. Okay. Now, the goal is to levitate the paper clip. Okay. So you see that? Now, I'm going to put some weight on the plate or hold it with your hand and let's see. Try to levitate and bring it to 12 o'clock position. So stretch it enough that the paper clip is not touching the cup, but it's still following the cup.
I got it for a second and then
Yeah, it needs a little bit of practice. It's not touching the cup, but it's still following the cup.
I was actually going to do something like this for a science assignment.
Yes. Noah.
I just recognize if you hold the cup too much, but like a little bit more
I got it.
off,
Mhm.
I didn't get it.
then it still sticks, but it's floating up.
That's right. That's our goal. So our goal is to see that because the magnet has a magnetic field, it still has that power to pull, attract the paper clip. If you see, I'm not sure whether you guys can see me. Let me put myself in on spotlight. Okay. So the paper clip is not touching the base of the cup, but it's still following the cup because of the magnets, because the magnet is pulling it.
I can get it to do that like I just did.
Who wants to show me?
If you can see it, it's
Let me. So raise your hand. Who was Alex?
It was floating. Just a second. It's floating.
Oh, wow. Great. So that's really good. Yes.
There.
I want to show.
Raise your hand. 1 second. Who wants to show? Raise your hand. Liam, right? Let me put you on spotlight. Okay.
I'm still spotlighted. How do I unspotlight myself?
Yes.
There.
Oh, yeah, I can see.
They're on their edge there.
Really good. Yes. So you just have to be far enough that it stays with the cup. Great job. Great job. Good job. No, Noah. I can't hear you, honey.
So this is like
Okay, let me put you. Yes.
so wait, this.
Yeah, I can see that. I can see that magnetic force on the paper clip, and it is not touching the cup, but it's still moving. Now move towards the center, like 12 o'clock position, and you see that paper clip is still following the cup. Awesome. Good job. Okay, so that's really good. And you saw that how even though the paperclip is not touching the magnet, you are still able to, the force is still able to move the paperclip from one point to another, right? Let's test the power of this magnet and make our magnet powered car, okay? So let's start that, let's do that. Anyone else wants to share before we move on to the next one? Okay, so I want you to take the car out and your jumbo popsicle stick. And so you remember I told you about the North Pole and the South Pole of the magnet? And the like poles repel, push each other. So I want you to tape one magnet on to the craft stick with a tape, okay? It will look like this. Let me put myself on to spotlight. One second. Okay, so tape the magnet onto the stick, one end of the stick, like this. So it'll look like this.
One of the magnets, not both of the magnets.
One, only one. Just one. And give me a thumbs up if you're done. Great job, Sean. Awesome, Samuel. Great, Lucas. Good job, Connor. So shall we move to the next step? Thumbs up? Okay, great. No? Okay. Wait for him. How is it going, Soren? Were you able to stick the magnet? Just tape it.
Magnet was on first for like a few seconds. For
Okay.
like, then like something pulled it off. So,
No worries.
yeah. My
So
friend always tells me patience because our Minecraft worlds have to log in, and I'm always so excited to log into his world every like weekend. We get to do that, so like.
okay. Meanwhile, I want you all to take that Velcro strips out, both of them. Okay, so we'll use one dot on top of the car here, okay? So I'll show you. So I'm gonna stick one dot up here.
Mine's more of like a racer car. Mine's different than yours.
Yeah, everybody has a different car, right?
Yeah,
So
I was
let's
expecting them to be different colors, but
stick one dot here Okay. So
Mine doesn't have a roof. It has a hole in the middle.
can I have a look at it?
Yeah, mine has a hole in it.
Okay, it's a hole. If you have a hole, then we can use tape. So I'll tell you in a minute, okay? So all others who can stick,
I have an idea. How about I just tape over the hole?
yeah, you can do that too. So you're gonna take your other magnet, okay, and bring close to the magnet on the stick and observe whether it's repelling or sticking. It should repel. Yes. Lucas.
I don't have 2 magnets.
You don't have two magnets?
No, they're sticking together at first. So maybe you might notice they're sticking together at first. So
When we started the class, you had two magnets? No? Check it in your lesson 1 support guide.
actually, I thought they were all. They were both at first. They were all just stuck. Both
Yeah, you thought they were
stuck together. So
I did
like.
too.
Never mind.
Okay.
Stick to the other one.
Okay. So what we're gonna do is, it's repelling, right? Mine is not sticking, it's repelling. So this is the end that will go up and put on the car like this. So this is outside, this end comes out. So how you're going to stick is you're going to take the other Velcro dot, which is the, if you put the fuzzy one, then take the other one and then just stick at the back of the magnet and just stick it to the car like this. You can do this way, or you can just tape the magnet to the car. I did that here. So I just tape the magnet to the car. You can do this way too.
Like, was it the positive way that goes to the negative, or the one that like
It repels. It should repel, not, it should not.
which one which one has the sticker on? Is that the repelling one? Like which side? The repelling
The one that attracts will have the sticker on, not the repel one. Repel one is outside.
Okay.
And if you mess up by mistake, it won't affect that much. I know how to go around it. So that's okay. You put the sticker on the other side.
How is this hi? How is this?
Yes, no.
Confused about how this will propel itself.
So so while I was like doing this, it doesn't stick because there's like something going on when I stick it on.
Okay, let's do, so you're going to stick the magnet on top of the car, not the bottom, okay? Top of the car, roof. So if your Velcro, if you are not able to stick with the Velcro, what you do is you're going to take a piece of tape and tape the magnet around, just like I did here. You see that? I taped the magnet. And I see that Liam has already started racing. Great.
How does it propel itself forward? I'm confused. Oh, I see how.
So I'm going to tape this magnet to the car.
I just put tape over the hole and slap the Velcro on the tape.
What did you say, Alex?
I just taped up the hole and slapped the Velcro on the tape.
Yes. taping is more permanent. It helps. Yeah, I think so. So if you can tape your car or the magnet on the car,
I still have Velcro, I taped
that's okay.
over the hole and added the Velcro on top of the hole.
So am I on Spotlight right now?
Yes.
Okay.
So
So
wrong view.
So let me show my work area here. Okay.
Yeah,
So you see that, how it's moving? Let me start from here. So what if I want you to all try that first. You can build a racetrack and have a car race.
Or an obstacle course for your car.
Obstacle course will be a better
Or
idea.
like a car course. I just call them car courses. Or car talent show. I don't know.
Yes, Lucas.
I don't really want to tape this on there because I want to play with these magnets.
You want to take what?
Like them, once I'm done with this thing, I can put the thing back on. But the most important thing, but I cannot put it on here.
Oh, you can put it on here. One way to put it on here is put with the tape. If you don't want to put with the tape, you can use the Velcro dots. So you have two types of Velcro dots. One is the teeth one. The other one is a fuzzy one. So you put one on the car and the other on the magnet, and then they'll stick to each other. Okay, so and that way you don't have to take the tape out when you want to use the magnet on some other thing. So who wants to share? Yes, Noah, you have a question?
I wanted to share actually.
Yes, so I will put you on Spotlight. Yes.
So when I can't kind of move the camera.
Okay, this is good enough. Yeah. Here we go.
So like it stays like that. So like I need help. So this is what it does. I think like.
Yes. Very good. Anyone else wants to share? Samuel.
You can use the Velcro for other things.
Let me put you on Spotlight. 1 second. Okay, Samuel? Okay, yes. I liked how you taped it. Awesome. And awesome, Samuel, that's great. Now, what do you think will happen if you flip that? If you use the other end of if you flip the stick? Yes, that's what happens. The car just get stuck to the stick. And why do you think that's happening? Liam.
Because I think it's happening because of the it's the North Pole and South Pole. I can't remember. I think it's north to north it will repel, south to south it will repel, but north to south it will come together.
Awesome answer. Yes, north, the opposite poles, whether north, south, or south, north, they attract. The like poles, if they are both north or both south, they will repel. So because they repel, you are able to use it as a car race, right? You're able to move the car. Anyone else wants to share? Great answer. Good job, Liam. Yes, you want to share? I'll put you on spotlight. 1 minute. Okay, yes.
I don't want to share, but
Wow, that's
I
nice.
do want to do something like math science matters. Boom.
Great.
It's done. Tape over my camera.
So That was awesome. So what do you think? What did you learn anything new?
Kind of.
Raise your hand if you did learn something new today. Anybody wants to share what they learned? Yes. Dawn.
I learned that I can do this like oh I did I did not know at first the car could do this and stuff, but now I learned it, and it's kind of fun.
Awesome. I'm glad. So in our next class, we are going to make our first mini robot. Okay. Rem wanted to share something. Yes, Rem.
I like robots, and also my car flips over sometimes when I use it.
So yeah, why? You know why? Because the magnet, if you see this, if you look at the car, let me put myself on spotlight. Why that's happening? Because this magnet has a north or south pole here too. So when you go really close, this part of the magnet gets attracted here and it turns and flips. That's the reason. So it's just a practice. With practice, you will be able to move it without, without it flipping. So let me try.
Yeah.
You see that? So if I come to this side, it's going to flip. Okay.
Can I share something you can like and do with the car?
Okay. Yes.
First, I have to find out how to stand up.
Okay. Let me put you on spotlight.
So on the plate, you like put a bottle and put it like kind of like on this, you like put a bottle on it and put it here, and then you like put this here, and then like put two obstacles to put it here, and then like see if it's not gonna trap or not. Like well, because when I tried it, sometimes it like attracted up. So you can like see if it will do it or not.
Yes.
After.
Yes, you guys can try obstacle course and tell me next class what else you did with this. I would love to see that. Okay. All right, guys. I'll see you next class, and it will be our first mini robot. So I'll see you next Tuesday, 4 p.m. Bye. Good night.
Okay.
Bye-bye.
Bye.